Yeah, that question, right?
Yeah, you have it?
Yeah. Is this?
Yeah, correct. Yeah.
Okay.
Because initially there wasn't, and then they gave it to us halfway.
Okay.
Okay.
Okay. The question says that a 50 centimeter into 50 centimeter circuit board that contains 121 square chips on one side, which is to be cooled by combined natural convection and radiation. Okay. By mounting it on a vertical surface in a room. Okay. Vertical surface in a room.
Yeah.
Okay. Let's imagine the diagram. It would be like this. Imagine this is a surface. And it is to be cooled by radiation and natural convection.
Okay.
Only one side of it might be getting cooled. On vertical surface room. Okay. This is room at 25 degrees Celsius. Okay. So let us say there are two modes of heat transfer from this surface. One is Q convection and one is Q radiation. Okay. That will be
why is it convection and radiation?
They have said that it is getting cooled by combined natural convection and radiation.
Oh, okay.
Okay. So it's like part of the heat will get convected and part of the heat will get radiated.
Okay.
Okay. So that would be the condition. They have given the area of the board. Area of the board, it is 50 centimeter by 50, so 0.5 into 0.5 meter square.
Yeah.
So it has got 121 square chips. Okay. Does that matter? I'll see. Okay. So
yeah, that's where I got stuck when I was doing it earlier. I took times 121, but the lecturer didn't, so I got confused.
A 50 centimeter into 50 centimeter circuit board contains. Okay. See, entire board has got this area.
Yeah.
So if you look at the cross section, it would look like this. This would be the cross section. It will be 0.5 by 0.5 and it will have 121 chips.
Oh, so you don't have to take them individually.
They have given us the entire surface area. So I think it doesn't matter. Okay. So I just go through the question first because I don't know what they are asking about and why have they mentioned the 121 squares.
Yeah.
And 121, is it possible to spread 121? 11 11s are right? Yeah. It's like horizontally there are 11 and vertically there are 11 chips.
11, yeah.
So it will be 11 into 11. Okay. So on a surface of 20, each chip, this is okay. Each chip, okay. This is the reason why they have given us 121. Okay. Yeah. So it's like the total power that the circuit board would emit is 121 into 0.18.
Oh, okay.
Okay. And the emissivity of the chip, epsilon, is given as 0.7. Okay. Assuming the heat transfer from the back side of the surface to be negligible. So this side is kind of insulated. So there is no heat transfer from this side. The heat transfer is only from one of the side. Okay. It's like, the one part of the room is getting is releasing heat and the other part is insulated. Okay. The temperature of the surrounding surface to be same as the air temperature of the room. Determine the surface temperature of the chips. Evaluate air properties at film temperature of 30 degrees Celsius. Okay, so these are the values which must be given at 30 degrees Celsius, right? Yeah. Yeah, because they might give you a table and from that table you need to get these values. What do they mean by film temperature? Mean film, actually it is mean film temperature. They should have written here mean word. Okay. It is mean film temperature. Okay. And mean film temperature is the average temperature at which all these properties are calculated or obtained.
Oh, okay.
Like I'll just go through previous topics. Let us say these questions. In this question, they have already given us K, PR, new, CP, rho, right?
Yeah.
Okay. So this is because they have given us, so we don't have to calculate. If had they not given us, then we need to find them at a particular temperature.
Okay.
And that particular temperature is basically mean temperature. Mean temperature is like if the surface temperature is 40 and the fluid temperature is 20, mean temperature is 30.
Okay.
So at that 30 degrees Celsius, you need to calculate this. Okay, because you need to find the temperature of the surface. That's why they are like, okay, consider some film temperature 30 and get the values at that temperature.
Sorry?
They are like, just assume that mean film temperature is 30 and get the values.
Okay. So they give us the values at 30 degrees.
Because unless you have these values, you actually cannot calculate H.
Okay.
So that's why they are like, they need to help you out. So just to help you out, instead of giving the values, they should have actually given these values in that case.
Okay.
Because they haven't given this value, they must have given table below the question or maybe behind the question paper. So from that table, you need to get all the values like K, new, PR, mean film, and these CP, all the values for which is required to find Grashoff's number and Prandtl number.
Okay.
Okay. Because using those numbers only, you can calculate Nusselt number.
Okay.
Right? Okay.
Yeah.
So the question looks very straightforward and looks easy to me. Let's try to solve.
Okay.
Okay. I will try to solve it from one of the corner.
Okay.
See, we already have total Q. We already have total Q. I hope you understand why you have total Q.
Is it the 0.
It is the 0.18 into 20.
Yeah.
Okay. This is in watt. This is the total power that chips are supplied, and that will get converted into heat. And
Okay.
this will be equal to Q radiation plus Q convection.
Okay.
Understood?
Yeah.
Okay. So all you have to do is just substitute the formula of Q radiation and Q convection. We know the formulas. Q radiation is basically epsilon A sigma
Changing.
surface raised to 4 minus T atmospheric temperature raised to 4. Right?
Yeah.
This would be the formula for Q radiation.
Uh-huh.
I hope you know the formula, right?
Oh, yeah, yes. It's just, yeah.
Okay. And you have already written the formula of convection. Formula is A surface Ts minus T infinity, right?
Yeah.
Ts is surface temperature of the circuit board, and T infinity is the temperature of the atmosphere. Right?
Yeah.
Out of which we know the T infinity, which is 25 degrees Celsius.
Okay.
Right?
Yeah.
We need to convert it into Kelvin. Okay. Whenever you solve the question for radiation, make sure the temperatures are always in Kelvin.
Kelvin. Okay.
So T surface would be 25 plus 273.
Okay.
It becomes 298. 298 Kelvin, right?
Yeah.
Okay. So that is T surface. We need to calculate. Sorry, T infinity. This is T infinity. And we need to calculate T surface. T surface, we'll see. We need to find it by substituting these Qs and equating it by this Q. So let's see what all values we have for Q radiation and Q convection. Like in this case, we have the value of epsilon. Epsilon is 0.7.
Okay.
Emissivity, right? Area in both the cases would be same. It is equal to surface area, and that will be equal to 0.5 into 0.5.
Okay.
Because they have already given us the area, which is in contact with the fluid and the radiating area, right? So that will be A. So we got epsilon we've got A, and sigma would be 5.67 into 10 raised to minus 8, 5, 6, 7, 8, right?
Yeah.
5, 6, 7, 8. Okay. So we have epsilon, we have A, we have sigma, we have T infinity. Only unknown is T surface.
So we can just shift it around to find T surface.
Okay. One more thing. In this formula, there used to be another term called as shape factor.
Okay.
Okay, shape factor is F, if you remember.
Uh-huh.
Area factor or shape factor. Do you remember?
Mhm.
This formula will be multiplied by shape factor also. But because circuit board would be very small compared to the room in which it is kept, that shape factor will be equal to 1.
Okay.
We had a discussion on the shape factor. I hope you remember. The relations we had discussed, like A1 F12 is equal to A2 F21. Do you remember?
Yeah, I think so, yes.
This was a reciprocal relationship.
Yeah.
Okay, I'll do one thing. I'll just revise some part of the radiation for you.
Okay.
Okay, before I write the radiation formula, you should know how to remember the main formula and then just jump up to the formula which you need to use.
Okay.
Okay, Q formula of Q radiation in general, what you must remember always is sigma T1 raised to 4 minus T2 raised to 4. T1 would be temperature of one body, T2 would be temperature of another body.
Okay.
T1 would be the body which is radiating, T2 would be the body which is absorbing. In this case, the T surface is the body which is radiating, and this would be air which is absorbing, right?
Okay. Yeah.
And then below this, there will be 3 resistances, which is 1 minus epsilon 1 upon epsilon 1 A1, right?
Yeah.
Plus 1 upon A1 F12 plus 1 minus epsilon 2 upon epsilon 2 A2. Have your teachers or have your faculty shared this formula with you?
I didn't think so. Can I just check the formula sheet?
Okay. This is called as surface resistance, and this is space resistance.
Oh yeah, they have.
They have?
Yeah.
Okay. See, if they have shared the formula, I think apart from all the other radiation formula, forget about them. Just remember only this formula.
Oh, okay.
Because this formula can be simplified to any other formula. This is the main general formula.
Okay.
Okay. How to remember this? Okay. Sigma is the Stephen-Boltzmann constant. T1 and T2 are the temperature of the body which are radiating and receiving.
Yeah.
Epsilon 1 is the emissivity of the radiating body.
Uh-huh.
Epsilon 2 is the emissivity of receiving body.
Okay.
Okay. A1 is the area of emitting body. A2 is the area of receiving body.
Okay.
Like if there are 2 bodies and there is net radiation transfer, this will be 1 and this will be 2. Okay. This will have area A1, this will have epsilon 1, this will have F12, this will have area A2, this will have epsilon 2, and this will have F21.
Okay.
Okay. So epsilon 1 is emissivity of this body. Epsilon 2 is emissivity of this body. Area A1, area A2. F12 is the shape factor of body 1 with respect to body 2. F21 is the shape factor of body 2 with respect to body 1.
Okay.
Now, what does it mean? It means how much part of the radiation of body 1 will be falling on the body 2.
Okay.
Because radiation doesn't go directly in one direction, right? The radiation goes like the rays from the sun.
Okay.
Right?
Yeah.
So the body radiates in all the possible direction. And only part of it will be intercepted by the other body.
Okay.
The part which is being intercepted directly is nothing but the fraction of the radiation being incidenting on that body. And it is nothing but the shape factor.
Okay.
The shape factor is basically the fraction of radiation which is falling from body 1 on the body 2.
Okay.
I hope you understand now shape factor, why, what it is and how important it is.
Okay.
Right? So now you can easily understand that if there is a room and if there is a small body which is emitting, you can easily imagine that entire radiation from that body will be intercepted by the room.
Yes.
Right?
Yeah.
That's why in this case, when there is a circuit board inside a room, entire radiation of that circuit board will be directly intercepted by the body. That is room.
Okay.
That's why F12 was taken as 1.
Okay.
F12 1 means 100% of the radiation from body 1 is falling on body 2.
42. Okay.
Right?
Yeah.
Okay. So the entire story concludes that we can take F12 as 1. We can take F12 as 1. But not just F12, let us simplify this formula for you to use it for this question.
Okay.
Okay. In this case, because A1 is very small compared to A2. A1 is very small compared to A2. What we will do is we will take A1 common from this three ratios. If I take A1 common from these 3 ratios, it will look like 1 minus epsilon 1 upon epsilon 1 plus 1 upon F12 plus A1 upon A2 bracket 1 minus epsilon 2 upon epsilon 2. And the entire bracket will be multiplied to 1 upon A1. Did you understand what did I do?
Yeah, you factorized A1 out.
Exactly. I took A1 common out of all the 3 ratios.
Yeah.
Okay. So now you can see, since A1...
How did you take out from the last one?
If I multiply A1 now into the bracket, the A1 will cancel out. Look at this and look at this.
You're just multiplying A1 into it?
No, if you factorize the entire, you can say all the 3 values.
Yeah.
A1 should be in the numerator of this fraction, right?
Why exactly?
Okay. Let's say we will do it reverse. What if I open the bracket? Okay. If I open the bracket, this will look like 1 minus.
Oh, okay, I get it.
Right? Okay.
Yeah. Okay, got it.
Okay. Good. So let's proceed. Yeah. Now you should understand A1 is very small compared to A2.
Yeah.
A1 is very, 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 very small compared to A2.
Yeah.
So it means this ratio will be negligible.
Okay.
Like if it is infinite times smaller, a small pin, a small board compared to room will be infinite times smaller, right?
Yeah.
So this fraction will get smaller and negligible.
Yeah.
So what exactly is being negligible? Like it might be of a value equal to 0.001 times something, 0.002 times something. It means even if it is 1,000 times smaller, it can be treated as negligible.
Okay.
Right?
Yeah.
Okay. So this can be eliminated. And all you will be left with is this.
Okay.
Okay. I just told you that
so for every situation it's negligible, is it?
Only for situations where body 1 is very small compared to body 2.
Okay.
It's like in a room or in a space, if something is kept, in that case, you can take this as negligible.
Okay.
Then, okay, one more thing. When A1 is very small compared to A2, F12 will be 1. What does it mean? It means a radiation of body 1 completely is intercepted by the body 2.
Because body 2 is larger than body 1.
So whatever that is coming out of the body 1 will fall on body 2. Not a single part of it will get wasted or get diverted to anything else or any other place.
Okay.
Right?
Yeah.
So F12 will be 1. So if F12 becomes 1, this will be 1 upon 1.
Yeah.
Okay. So now let's simplify only this part. Let us simplify only this part, and I can take A1. I can keep A1 as it is. Okay. So now this will look like 1 upon A1 bracket 1 upon epsilon 1 minus 1 plus 1, isn't it?
Plus 1, yeah. Oh, -1. Okay.
Right? 1 upon epsilon 1 for this. Epsilon 1 upon epsilon 1 becomes -1.
Mhm.
And 1 upon f1 to become +1. So they will get cancelled out, 1 and -1 +1.
Yeah.
So you will be only left with 1 upon a1, 1 upon epsilon 1.
Yeah.
So this is the only part left for this entire denominator.
Yes.
And your Q radiation will look like a1 epsilon 1 sigma T1 raised to 4 minus T2 raised to 4.
Okay.
So I hope you now understand why it is taken directly as this formula.
Yeah.
Right? So what you need to remember that if a body 1 is very small compared to body 2,
Mhm.
this entire formula can directly be simplified to this formula.
Okay.
Right? If body 1 is very small compared to body 2,
Mhm.
this entire basic radiation heat transfer or radiation formula can be simplified to this. And now we can proceed and use this simplified formula only. Okay.
Okay.
We will use the other relation for only radiation related numericals.
Okay.
Okay. So now let's proceed. And now we've got radiation formula. I hope it is very clear to you now.
Yeah.
Okay. Q convection formula, you already have it. So we have A1. A1 will be equal to AS is equal to 0.5 into 0.5.
0.25.
0.25, yes. Meter square.
Yeah.
Okay. Then epsilon 1 is equal to 0.7, which is emissivity of the board.
Yeah.
Sigma is Stephen Boltzmann constant. 5, 6, 7, 8. Okay. T1 is taken as 25 plus 273, which is equal to T infinity, equal to 298 Kelvin. Okay.
Okay.
Okay. T1, sorry, it is T2. It is T2. Right? T2 is the temperature of the room. So it is T2. Okay.
Is it T2 or T infinity?
T2 and T infinity are same. Okay.
Okay.
T2 and T infinity are same.
It's basically the surrounding temperature, right?
I have written things in the form of T2 just for the generalized case.
I
T2
see.
is the body which is taking the radiation. So it is atmosphere which is taking the radiation.
Okay.
Right? So T2 will be equal to T infinity equal to 298 Kelvin. Okay.
Okay.
Okay. So now I think we have all the terms except T1 over here. And T1 is nothing but T surface.
Yeah.
Now let's see what do we have with convection formula. We need to find value of H before we can solve this question.
Yeah.
Value of H can be found or can be calculated by Nusselt number.
Yes.
Nusselt number can be calculated by using the relation for Nusselt number in the form of RAPR or GRPR.
The 0.59 RA to the power 1/4.
Okay, wait. We have a table for natural convection, right? The list of formula which you had sent to me.
Yeah.
It will have a table to find. See, now this is external natural convection. Okay.
Yeah. So it is a vertical plate.
Perfect. So range of RA is given. For range of RA 10⁴ to 10⁹. Nusselt number equation is given, and range of 10⁻10 to 10⁻13 Nusselt number is given, right?
Yeah.
Okay. So we need to first find the value of RA.
Yeah.
Okay. Now you have written something, but let's see what exactly RA is. RA is equal to GRPR.
Yeah.
It is Grashoff's number. Grashoff's number. How do you remember the Grashoff's number?
Gravitational.
G beta delta T, right? G beta
Delta T.
T L cube upon nu square, right?
Yeah. Correct.
Okay. G is gravity. Beta is mean film temperature. Mean film temperature is already being given to you.
30. Do I need to change that to Kelvin?
Yeah, you need to.
Okay.
It will be 1/30 plus 273, which is equal to 1/303.
Okay.
Okay. So that will be beta. Delta T, you don't need to convert it into Kelvin because it is difference, right?
Yeah.
But we don't have delta t. How to find the value of delta t now? How did you get this value?
The teacher gave me, but I felt I didn't get that value. I got 0.7282.
No, you don't have t surface. How can you find delta t?
Oh, I used 35 minus 25.
35 minus 25.
Yeah.
Okay, I understood what you did. See, what exactly the situation is, let us talk about it. The situation is basically we need to find GR, we need to find Grashoff's number, and without Grashoff's number, we cannot find RA. We cannot find H. And for Grashoff's number, we need to have this delta T. What is delta T? Delta T is temperature difference between
the room and the surface.
Yes. Delta T is Ts minus T infinity. Now they have given us mean film temperature.
Yeah.
What does it mean? Now this means Ts plus T infinity divided by 2.
Yeah.
Okay. So from here also we can find Ts.
Okay.
Because we have this value of 30 and we have this value as 25.
Yeah.
So this would look like 60 is equal to Ts plus 25 and Ts is equal to 35.
Yeah.
Okay. Now the question would be that if we can get Ts as 35 from here, why are we solving this question? Because ultimately we are solving this entire question for the sake of Ts only. Right? So does this Ts signify the actual Ts, or it is only for the sake of finding the value of H? So it is just an average value or approximated value. Okay. This is an approximated value given just for the sake of calculating the value of H.
Okay.
So this is not the real Ts.
Okay.
It is not real Ts. It is not real. It is approximated value. Okay.
Okay.
This approximated value is given just to help you out and help you calculate the value of H. Because if you don't have this Ts, you cannot calculate Ra. You cannot calculate Ra, so you cannot calculate Nusselt. You cannot calculate Nusselt, so you cannot calculate H. So ultimately, you get into a fixed situation where you cannot find anything.
Okay.
So this is used, or this is done just for the sake of convenience. Okay.
Do we have to make an assumption or anything?
This is kind of assumption.
Must we state it?
This is an assumption that since they have given us mean film temperature, the mean film temperature is nothing but mean value, average value of surface and fluid.
Yeah.
Right?
Yeah.
You understood the formula?
Yeah.
Now you must have understood from where you got the 35 value. Earlier you had this idea from where you get to 35?
The lecturer went through it.
Yeah, exactly. He did the same, but maybe he did explain why from where you got the value 35.
Okay.
Okay. See, 35 is simply an approximated value, which is calculated by using the mean film temperature, which they have given us as 30.
Okay.
Okay. Mean film temperature is 30, which is substituted over here. Infinity is atmospheric temperature 25, and from there we could calculate Ts, which is 35. Now, since Ts is 35, we can calculate delta T. Delta T is Ts minus T infinity, and this is equal to 35 minus 25 equal to 10.
Okay.
Okay. Now we have delta T, we have T mean. What was T mean? Sorry. Delta T, I needed beta. Beta is equal to
1/303.
1/303. So now let us substitute over here and calculate the value of GR. GR is equal to,
I calculated GR as 0.7282.
okay, let me substitute and then we can use it, see it again. Or maybe just cross check if you have substituted the same.
Yeah, I'll check again my values.
G is 9.81. Beta is 1/303. into 10. Okay. Upon new is 1.608 into 10 raised to minus 5. And this whole will be multiplied by L cube. L is 0.5 raised to 3. Right?
Yeah. Correct.
So was this the exact value you have substituted?
Yeah. Let me just try it again.
The only mistake you can do is the value of beta.
No, I got. Oh, now I got a different number.
You must have taken beta in degree Celsius.
Yeah, I guess.
So how much
So
is
now
it?
I got 2516.
It is 2516.
0.809.
0.809. Okay. Now we need to multiply this by PR. Use this value and multiply to this. Okay. Sorry. We need to square this value.
Oh, no wonder. So, okay. Give me a second. So the temperature difference, I don't need to take it in Kelvin, right?
No. The difference remains always same, irrespective of it is degree or if it is in Kelvin.
Okay.
Because it is different between the two magnitudes.
Some error in my calculator. Give me a second.
Okay. Get my calculator.
Okay, no, what went wrong? Yeah, I'm not getting it at all.
How much did you get?
I got like 15 something, like super big number.
Yeah. Just press the button of ENG. ENG, once you press, you get the good value of power.
Okay.
It is H studio ENG, some button over there. Okay. See, in every calculator, there is a button called as engineering button, ENG. Once you press that button, you get the value and the power. Could you calculate?
Checking.
9.81 into 1/303 into 10 into 0.5 cube divided by 1.608 10 raised to minus 5.
So what calculator? Oh, I found it.
Every calculator has it.
Yeah, I found it.
See, now this looks like this. So it is very difficult to write it down. What I will do is I will press ENG button. Once I press ENG button, it looks like 156 point something.
Also, it changes it to standard form for us, is it?
Yes. It gives us the standard power.
Okay.
So now
I got 156.51 times 10 to the power 6.
Oh yes, into 10 raised to 6.
So
Now,
is this correct? Because the lecturer got that.
No. He has multiplied to Prandtl number. Let us multiply to Prandtl number now.
Okay.
Into 0.7282. See, we got the exact value.
Okay.
We got whatever he got.
Okay.
He got the value of 1.14. We got the value of 1.1397.
Yeah.
But that will do. It is 1.1398.
Yeah.
Into 10 raised to 8. Okay. So
Prandtl number is given to us, right?
930. Sorry.
Yeah, it was given to us. Okay, no, just checking. Okay.
Okay. Yeah. Sorry. Yeah. Say.
Yeah, got it.
So you got the value of RA?
Yeah.
Okay. So now let's go to the table. Let's go to the table. Table shows that for the range of 10 raised to 8 to 10 raised, 10 raised to 4 to 10 raised to 9. Ours is 10 raised to 8. So it is within the range of 10 raised to 4 to 10 raised to 9, right?
Yeah.
So we will use the equation of Nusselt number is equal to
0.59 RA
0.59
of 1/4.
RA raised to 1/4.
Yeah.
Okay. Easy. Simply multiply the answer. No. Now answer raised to. Answer.
I got 60.964.
Okay. 0.59. It's 60.96. Correct.
Mhm.
60.962. So using this, we can find the value of H. H
Yeah.
Nusselt is equal to HL by K. Okay. Here the L would be 0.5. Right?
Yeah.
And K would be K is already been given.
0.02588.
Yes. Let us find the value of H. H would look like answer into 0.02588 divided by 0.5. 3.1556.
3.1554, right?
Perfect.
Okay.
So did our value match with your professor's value?
Yeah.
Okay. So now I think question looks easier. And all you have to do is simply substitute the values. Now, the last step would be add the values and equate it to 0.18 into 121. So I'll take some other color. It should look like 0.18 plus 121 is equal to Q radiation plus Q convection. Q radiation plus Q convection, right? You got this?
Yeah.
Okay.
Correct. Yeah.
So this will be like this entire value. Surface area is 0.25.
Mhm.
Then emissivity is 0.7. And then sigma is 5.67 into 10 raised to minus 8. Bracket open. T1 raised to 4 minus 298 raised to 4.
Yeah.
Plus. Okay. Plus. Now I will substitute this. It will be H. H is equal to 3.1554 into 0.25. Right?
Yeah.
And then it will be multiplied to delta T. Delta T would be T1 minus 298.
Yeah.
Okay. Now in this entire equation, only T1 is unknown.
Yeah.
Can
So
you
we
solve it in the calculator?
Yeah, you just change it around and find T1, right?
Okay. You can find can you use the calculator to find the value of T1?
Yeah, can.
Oh yeah. Do you know the method to solve it? Like the shortcut method?
No.
Okay. Do you have a symbol like X in your calculator? Take a photo of your calculator and send me.
Okay.
Okay. Yeah, there is. See, if you can see that bracket close symbol has X.
Oh yes.
Right?
Okay. Yeah.
And you also have a button called as alpha beside the shift button. Right?
Yes. Yeah.
Okay.
So alpha and then the bracket, is it?
Okay. And now all you have to do is now make the equation exactly like how it is looking in front of you.
Okay. Including the 0.18?
Everything. everything, whatever is there in front of you, or you can do one thing. Take that 0.18 into 121 on the other side of the equation. So this will be like 0 equal to, right?
Yeah.
This will like 0 is equal to, this will be
all this minus that.
1 plus equation 2 minus this.
Okay.
Right? So just write it down in your calculator. You
Okay,
can,
T1 and X, is it?
you can substitute everything. You can, instead of T1, just press alpha and X.
Okay, I tried.
Okay. I will also write it for you. You also try. So 0.25 into 0.7 into 5.0, no, 5.67. 10 raised to minus 8. Calculator is very similar to my calculator, actually.
Oh, okay.
Alpha x raised to 4. Minus 298 raised to 4. Bracket close. Plus 3.1554. 3.25.
I got minus 335.107.
No. It can't be minus. Alpha x minus 298 bracket close minus
67 times 10 to the power -8. X to the power 4 minus 298 to the power 4. Oh. Plus.
okay. Once you make an equation, what was the next step you did?
Just equal.
No, it shouldn't be solved by equal to, okay?
Oh, okay. So how do I solve it then?
Okay, there is only one or two buttons that are different, that we actually press shift. Okay, we press shift and there is a button of calculate just below that. So pressing the shift and calculate, after that it asks the value of x equal to 0, we need to substitute. And once we substitute x equal to 0, I got the value of 309.
Oh, okay, I do not know how to do this.
Okay.
Okay, I can just do it the long way, it's fine.
No. Why? You have to just learn it because it will be beneficial for you. It is very important. This is something which will help you out in entire engineering.
I can't seem to find how to solve it then.
Okay, you made the equation.
Yeah, I made the equation.
Once you made the equation, press shift.
Okay.
Okay. Did you press the shift?
Yeah.
Press that ABS.
ABS? Oh, ABS. Okay.
What does appear in front of you?
Nothing. Just the equation, still no answer, nothing.
Okay. Even after pressing ABS, it asks for nothing?
Yeah, nothing. Okay,
then do one thing. Now press equal to.
Yeah, still nothing. It's the previous answer.
See what actually is happening, it is taking the previous value of the calculation which you have done, which is not actually desirable. So the next step is something which differs in every calculator. Like in our country, there are many scientific calculators. This is one of them. So every calculator has that last step a bit different. But once you know that, it becomes very easy.
Okay.
Okay. Your calculator is Canon F965G. 965G. Mine is Casio. So maybe we can just Google out. Canon F960 SG. Do you know the long cut method? What would be the long cut method?
Sorry?
What would be the long cut method you would do to solve this question?
I would just shift everything and try to find T1.
Shift everything? No, you can't do that. There's a power of 4 given. You can see it is a fourth order equation.
Yeah.
So you can't do that at all. You have to learn this method. Like you need to learn to use a calculator. Canon F960. F960 SG equation. Solving method. Let's see if somebody has made a video out of for it or not. Okay. All I find in Indian videos and Indian people don't use this calculator.
What is your calculator, Brad?
Mine is Casio.
What model?
It is FX99ES.
Yeah. FX99.
FX991ES.
Oh, I used to use this calculator, I think, before. Just...
In a calculator, there is nowhere written the word calc. Had they written survey CLC, things would have been easier.
Yeah.
Why is that button ABS? What would be the purpose of ABS button?
I have no idea.
Okay. Just try to use that button and see what it shows.
The ABS alone?
Yeah.
Oh, it's like modulus.
Okay, it takes a mod.
Yeah, okay, so I'm just going to send you what I see.
Okay, ABS.
It's what I get if I press the ABS.
Okay. Once you press ABS, okay, that like a modulus. No, we don't need that. And once you undo, can you undo this?
Yeah.
Like, does your equation get deleted?
Yeah.
Okay. There must be some method to solve. Somewhere the calci must have explained anywhere, somewhere. Because unless you know that method, you can't solve any equation.
Yeah. Let me just try. Yeah, can't find it.
Can you find any video on this?
No.
Okay. Okay. Why did you buy this calculator? Like your college mates also use the same calculator?
No. Kids I teach. The kids I teach are using the same kind of calculators. So I just got a piece of that actually before I even started.
Okay.
Doing course.
See, there are many models of this calculator in which I can see calculate like CLC option, but not in your calculator.
Yeah.
Right. Is there an equation mode in the calculator? There should be an equation mode because there is an option to type x, right?
Yeah, no, because I think this calculator is not meant to be like that for the students, you see, they're sitting for exams. So these are approved lists of calculators by the government.
But because there is an option to type x in the calculator, there should be a method
way to solve. I was thinking of that too.
See, like I see this calculator. In this case, there is a button CLC. CLC.
Yeah.
Can you see it?
Yeah.
CALC.
Yes.
I'm searching for that CALC in your calculator. I can't see that.
Yeah, I don't see it either.
Okay. Maybe that ABS button is for that.
But I tried, it's not working.
Did you press that ABS directly or press the ABS after shift button?
After shift. So I keyed the equation, I pressed shift, and then I pressed the ABS.
Okay. Now try to type the equation again and press directly ABS. Let's see what happens.
Okay. No, it's just showing me the modulus.
Even without pressing, okay. Even without pressing the shift button.
Yeah.
Okay. Because without using that method, you cannot solve this question in exam.
Yeah.
Because there is no other option. Like you can't simplify. Okay, press the mode button. See if there is an equation mode.
Yeah, there is equation 4.
Okay. Then
there is option 3.
Click on the equation mode.
I did, and then there's a few options given.
Can you see the equation with power of 4?
No, there's only up to power of 3.
Okay, now see, this was one more problem. Like you can't even solve the 4th power equation in your calculator. So you'll have to learn that alpha x method.
Okay.
So
What
we
is alpha
need
x
to
method?
find somehow solution. Okay. Just try some permutation combination. Like make an equation, press the shift button and press the equal to symbol.
Using this equations or just this equation that you gave
Type
me?
Type the equation again.
Okay.
Or just for the sake of convenience, let's make some easy question. Like simply write down what can be an equation. Let's make our own equation. Like 5x square plus square. Let me have something like minus x square under root equal 500. equal to 0.
Okay.
Okay, let's make this equation. Okay, let's make this, just simply type this equation, 5x square minus 500,
Okay.
and press the button of shift and equal to.
Negative 500.
Okay. Shift and equal to negative 500. Okay. What all could be the other option?
Will a graphing calculator help?
What?
Graphing calculator?
What is graphing calculator?
It draws graphs for you.
No, not required. We don't need graph. We need the value of x.
Yeah. I mean, I think it can do that as well. I'm not sure.
Try if you can.
Let's get the calculator if I can find it first. Give me a second.
The last option can be like reading the manual of this calculator.
I can just send you what I have in this calculator. But I have not charged it yet, so can't use it right now.
Okay.
This is the other calculator that I have.
Okay, are you allowed to use this calculator in exam?
Yeah, I can use, no problem.
I haven't used this calculator ever.
I'm not sure how to use it, but it's a very expensive calculator.
Okay. And I don't know how to use it.
They made us buy it. I still don't know how to use it. So
Okay. I don't know how to use it either. So let's skip this calculator. Because
maybe I can go get a new calculator tomorrow. You know? Yeah. I
like
mean, it's
a calculator with alpha x something.
yeah, and with the CALC word, right?
Yeah, CALC, right? CALC option.
Okay. Can you just message me your calculator, the model number? I'll see if I can find the same one.
Okay, I'll just take a photo.
Yeah, for us to make calculations and. Yeah, I'll go and take a look tomorrow and I'll get it.
Okay, I sent you.
Okay.
See, the question part is over. All we have to do is simply just simplify this and using the calculator find the value of t surface. So
Yeah.
I will just make an equation and help you out. So it is 0.25 into 0.7. How did the professor solve this question? Simply just give the answer.
He didn't even solve it.
Okay.
He just said find this, find that, and he just gave the final value and yeah.
298. Alpha x minus 298 minus 0.18 into 2.12. Shift solve x0. Okay. So the answer that we have got 309.45. Okay.
Okay.
The surface is 309.46 Kelvin. To convert it into degree, minus 273.
Okay.
So it is 36.455.
Okay.
36.455 degrees Celsius. This is the answer.
Okay.
We approximated it to 35, but the correct answer is 36. Okay.
Okay.
I hope now understood that this was the approximate value, and now this is the exact answer.
Okay, I got some questions.
Okay.
Firstly, like, why did we find Rayleigh's number?
Oh, Rayleigh's number is to know which equation of Nusselt number can we use.
Okay. Then, like, what is the question actually asking us to find?
See,
Only the surface temperature of the chip, is it?
that is the only question. Yes.
Okay, because I didn't understand, like they said, evaluate air properties, and then is this a good assumption?
See, they have asked determine the surface temperature of the chip. Okay.
Yeah.
And is this a good assumption? What kind of good assumption are they asking about?
Yeah, that's why. Evaluate air properties at film temperature and 1 atm pressure.
Okay. See, after finding the answer, the T surface came near to the
The
assumed
one that
T surface.
okay.
So you can simply state over there that since the obtained T surface is 36.45, which is almost equal to 35 or near 35, the assumption can be said to be correct.
Okay. So what would be like a bad assumption? Like, I mean, not a good assumption.
We can't do that. Actually, this is something we normally assume. This is like normal temperature, atmospheric temperature pressure.
Okay.
Right? What is the NTP that is assumed to be over there? Normal temperature pressure. What do your professors assume? NTP?
Where's NTP?
NTP, normal temperature pressure.
I'm not sure.
Okay. See, this is like normal temperature pressure only. NTP value is normally 20 degrees Celsius and 1 atm. But they have assumed it to be 30 degrees Celsius and 1 atm. You know why? Because okay, is this assumption correct? Oh, sorry. The atmospheric temperature is already 25, right?
Yeah.
Atmospheric temperature is 25. So this is mean temperature. So mean temperature should be more than 25.
Okay.
Like if there are two values,
Mhm.
and if you're taking mean of the two values,
Mhm.
then the mean values will be in between those two values, right?
Yeah.
So if one of the temperature is 25, like atmospheric temperature is 25, and another body is emitting the radiation in that atmosphere, it means that body will be hotter than 25.
Okay.
So your mean temperature has to be more than 25.
Okay.
Okay. See, it's like you can say the chip is radiating and the atmosphere is receiving. The radiation is from hotter temperature to colder temperature.
Yeah.
If the colder temperature is at 25, the average, it means the sum of both and divided by 2 should be more than this value. That's why they have assumed it to be 30. And there is no other explanation about it.
Okay.
Had they not given us 30, this would have been a difficult question.
Okay.
Okay. I think we're done with the question.
Yeah.
Okay. Let's go for the next question.
Yeah.
Okay. I think that question is solely based on radiation, right?
Yeah.
Okay. Okay, there are 3 surfaces. Can you understand what exactly are the 3 surfaces? The first surface is the top of the cylinder.
Yeah, the curved surface.
And another is the periphery, right?
Yeah.
Okay. The furnace is of cylindrical shape with a diameter of 1.2 and a length of 1.2. Top surface has emissivity, this much, maintained at 500 Kelvin. The bottom surface has emissivity 0.5, maintained at this much. Side surface emissivity this much. Heat is supplied from the base surface at a net rate. Base surface. Heat is supplied from the base surface at net rate of this much. The temperature of the side surface and the net rate of heat transfer between the top and the bottom surface and between the bottom and the side surface. Okay. Okay. Question is a bit higher level question, but we can solve it. No issue. Okay. See, there are three bodies. Now, about radiation, what all formulas you must know. First of all, you must know the basic formula of radiation Q heat transfer, that is radiation heat transfer, and that would be the formula which we had discussed earlier. It is sigma is equal to T1 raised to 4 minus T2 raised to 4.
Yeah.
Upon 1 minus epsilon 1 upon epsilon. Instead of using 1, 2, I will use the suffix AB because
Okay.
they already have used the number 1, 2, 3. So let us not confuse. So this is like TA raised to 4 minus TB raised to 4 whole upon 1 minus epsilon A upon epsilon AA plus 1 upon AA FAB. I hope you understand.
No,
Okay.
because it was like 1, 2, and now it's AB.
Okay. So we will use the same 1, 2 only.
Yeah. It's easier.
So Q is equal to sigma T1 raised to 4 minus T2 raised to 4 whole upon 1 minus epsilon 1 upon epsilon 1 A1 plus 1 upon A1 F12 plus 1 minus epsilon 2 upon epsilon 2 A2.
Okay.
Familiar with this formula now?
Yeah.
Okay. So so 1 is basically the one which is emitting, 2 is basically the one which is receiving.
Yeah.
Okay. So we will have to use this formula twice.
Okay.
Okay. See, now understand that they have asked to determine the temperature of the side surface, like T3 is unknown.
Yeah.
And the net rate of heat transfer from the top and the bottom surface. Net rate of heat transfer between the top and the bottom. Like what would be 1 to 2 radiation? First case, it will be Q12. And between the bottom and the side. And next would be Q23.
Okay.
So they have asked us Q12 and Q23, two values of Q.
Okay, but the heat is from the bottom, right? So why is it from the top to bottom?
Yeah, that will be basically bottom to top only, no issues. Net rate means net exchange, and you can clearly see that the radiation will be from 2 to 1 only. No issue.
Okay.
Okay. So net radiation.
There are two things, right? One to the side and one to the top.
Yeah. So it
Okay.
will be between 1 and 2 and between 2 and 3.
Okay.
Right?
Yeah.
Between top and bottom and between the bottom and the side.
Sides.
So you need to find two heat transfer values. That is, one would be Q21 and another would be Q23. Right?
Give me a second. Why 2, 1? Where's 2 and where's 1?
Okay. The 2 is the bottom, 1 is the top,
Okay. Okay, I see it. Yeah.
3 is the periphery.
Okay.
Okay. I wrote it Q21 because looking at the temperature, we can make out that radiation is emitted from bottom to top.
Yeah, understand. Okay.
So it will be Q21 and Q23. So we will modify this formula accordingly. Now this formula is made for 1, 2, okay?
Okay.
Formula is made for Q12.
Okay.
So if we modify it for Q21, it would look like sigma into T2 raised to 4 minus T1 raised to 4 upon 1 minus epsilon 2 upon epsilon 2 A2 plus 1 upon A2 F21 plus 1 minus epsilon 1 upon epsilon 1 A1. Understood?
Yeah, understood.
I simply interchange 1 with 2.
Yeah.
Second formula would be Q23. See, Q23 would be sigma into T2 raised to 4 minus T3 raised to 4 upon 1 minus epsilon 2 upon epsilon 2 A2 I'll just change the
Sorry,
color.
I can't see.
Yeah, I'll change the color. Okay. So it is 1 minus epsilon 2 upon epsilon 2 A2.
Yeah.
Okay. Plus 1 upon A2 F2 3 now.
Okay.
Understood now?
Yeah.
Okay. Plus 1 minus, you say, what would be?
1 minus epsilon 3 over epsilon 3 A3.
Yeah, perfect. So now once we know what formula to use, the next step would be to find the values and it will get easier.
Okay.
Okay. See, this chart is given to find the shape factor. Okay.
Okay.
F12 and F12 and somewhere they must have written this is L by R. What is R? Achha, R is the radius. Okay.
Okay.
So R1, R2. Now over here the R1 and R2 are same. Right?
Uh-huh.
R1 and R2 are same. I'll just try to solve this question without using this chart first. But if I get fixed, then I will try to look for this chart. Okay. Like this chart, even without using the chart, maybe I can solve it. Let's see.
Okay.
Next step, I would be, see, I have the value of sigma.
Uh-huh.
I know the value of sigma. I have the value of epsilons.
Mm-hmm.
I know the value of A1 and A2.
Yeah, and you can find area and all, right?
A1 is equal to A2 is equal to pi by 4 d square.
Yeah.
Pi by 4 d square. D is 1.2. And what is A3?
Circumference times.
Yeah, circumference times length. It will be pi into 1.2 into 1.2. Pi dl. Pi dl.
Yeah.
Okay. So this is the surface area of the A3. So a value of A is sorted, value of epsilon is sorted.
Mm-hmm.
See, now the problem would be we can calculate this entire Q12 if I know the value of F21. Like the major issue or major problem comes with the shape factor only.
Mm-hmm.
Right? So just to find the shape factor, they have given us this graph.
Okay.
Okay, now this graph is like I'll have to use my brain to use the graph because I haven't used the graph ever. I can simply find the value of F1, F21. Like what are the various relations? The relations are A1 F12 is equal to A2 F21. First of all, this formula, this is called a reciprocal relationship.
Okay.
Second formula is for enclosure theorem. Enclosure theorem is F11 plus F12 plus F13 will be 1. F21 plus F22 plus F23 is equal to 1. F31 plus F32 plus F33 is equal to 1. Now, we should know that F11 would be 0.
Why?
Because radiation from the flat surface directly never falls on that flat surface.
Okay.
Like if this flat surface is emitting radiations, directly the radiations will emit and then fall on it.
Yeah.
So I think maybe that's why they've given us graph, because even though this would be 0, or maybe this would be 0, it is not easy for me to find the value of either F12 or F21.
You want me to share with you the video where he shows this?
He has used the graph.
Yeah, I think he has.
Okay, we will see that. Just let me see what exactly are the values in this.
Okay.
See, R2 is the radius of the upper surface. R1 is the radius of the lower surface. And L is the length. Okay. Now in this case, R2 by, okay, see R2 by L, because R1 is twice, is half the length. So I can say this value would be this much, right? Because diameter is 1.2 now. If diameter is 1.2, radius is 0.6.
Yeah.
So the value of R2 by L,
Sorry, your y-axis is your R, is it?
y-axis is F12, shape factor. We can
Oh.
directly get the shape factor by using the y-axis.
So why did you say 0.5?
Okay, I'll tell you again. See, what I'm doing is you can, if you see carefully in this graph, the ratio of R2 by L is given.
Oh, okay. Yeah.
Right? R2 by L is given.
Uh-huh.
So R2 value is 0.6
Yeah.
and L value is 1.2.
Yeah.
Right? R2 is 0.6 and L is 1.2. So ratio will be 0.5.
Yes.
So R2 by L is 0.5 that we need to use.
Okay.
So that's why I prefer not to see the recording, because unnecessarily we will be going through the content, even though we can make it out from here also.
Oh, okay.
See, this is the value we will be referring, or this is the line, this is the curvature we must be referring.
Okay.
Also, over here, they have given us the value of L by R1.
Uh-huh.
Now, L is 1.2,
1.2.
R1 is 0.6, it will be 2.
2, yeah. So you got a 2.
Yeah, wherever this line will intersect,
yeah,
this curve will give us the shape factor. And using this graph, I can find the shape factor will be approximately over here. To me, it looks like somewhere in between 0.1 and 0.2. I can take 0.1.
0.15. Okay.
What did your professor take?
I'm not sure. I haven't gone through that lecture yet.
Okay. But I hope you understood what did we do.
Yeah, I understood.
So from here, this graph should be really big, you know, like it is very difficult to find the value from here. Because we can't guarantee that it is exactly in between these two, right? We know that we have to refer this curve and this line.
Yeah.
I hope you understood that.
Yes, I understand.
And they both intersect over here.
Yeah.
At that intersection, I will draw a horizontal line to find the shape factor.
Okay.
Now, to me, it doesn't look exactly 0.15. It looks a bit more than 0.15.
Okay.
Can you like make out the difference? Like, see, this is 0.1. I think by approximation, the 0.15 would be here.
Yeah.
Just below that.
0.17?
No. 0.16 or 0.155 we can take.
Okay.
Right? Not 17. 16 we can take, right? We can take F12 is equal to 0.16.
Okay.
Are you convinced?
Yeah.
Okay. So let's take the value of F12 is equal to 0.16.
Okay.
Okay. See, this is F12. This is not F21.
Yeah.
We want the value of F21.
Right.
So now we will use this formula to, so maybe I need F21, right? So F21 formula is this one.
Yeah.
Okay. Oh no, sorry. I have the value of F12. I will substitute it over here.
Okay.
Okay. If we see carefully, A1 and A2 are same. A1 and A2 are same.
Yeah.
Since A1 and A2 are same, F12 will be equal to F21.
Okay.
Right? So
yeah.
F21 and F12 will be same.
Okay.
Okay. So this is the first part. We will substitute it over here and we can calculate the Q12.
Okay.
I think it is solvable now. This would be 5.67 into 10 raised to minus 8 into bracket T2 is 650. 650 Kelvin. Sorry, 650 raised to 4 minus 500 raised to 4 whole upon 1 minus, what is epsilon 2? Epsilon 2 is 0.5.
Yeah.
Epsilon 2 is 0.5 upon 0.5 into A2. Into A2. Okay, we can do one thing. We can take A1, A2 common because they both are same.
Okay.
Instead of substituting them every time, we can take it common outside and later multiply it in the numerator.
Okay.
Right? Like if we take it in the common from the denominator, will go in the numerator.
Okay.
It's like A upon B by C. A upon B by C can be written as AC by B.
Okay.
Right?
Yeah.
So similar way, we can take A common from the denominator and multiply it simply in the numerator in the next step. Plus
Okay.
1 upon A2 into 0.16 plus 1 minus, what is epsilon 1? 0.7.
7, yeah.
0.7 upon 0.7 into A. Into A. So I will take A common. What is A first of all? A is equal to pi by 4 d square.
Yeah.
Okay, just tell me the value. I think pi by 4 into 1.2 square.
4.52.
4.523.
523.
Okay, we will just substitute in the numerator. So
Okay.
it will be like 5.67 into 10 raised to minus 8. 650 raised to 4 minus 500 raised to 4 into 4 point into this value A.
Okay.
Whole upon this will be like 1 minus 0.5 becomes 0.5. 0.5 upon 0.5 plus 1 upon 0.16 plus 1 minus 0.7 becomes 0.3. 0.3 upon 0.3. Now just use the calculator, simplify it, and you will find the value of Q.
Okay.
21. Okay. You also do it. 5.67 10 raised to minus 8. 650 raised to 4. This should be 0.7. Okay. I got the value of 3874.455.
Three 3874. Yeah, correct.
Okay. So now this was the first answer. Okay. Second thing is before until we have the temperature of T3, we can't proceed because we need to find now we need to find the temperature T3. Okay. How to find the temperature T3? This can't be this much here. Something is wrong with the value. We have gone somewhere wrong because the net radiation coming from the base is 1400 watt. So this value should be less than 1400.
So can I go get some water?
Yeah, you can.
Okay, thank you.
Okay, 0.5 upon 0.5. Did you give me the correct value of area?
I check with your calculation.
Let's check the value of area. I'm doubtful about it.
Area 1, right?
Yeah, it has gone wrong. This value is wrong, which you told me. It is pi by 4 into 1.2 square. I think you forgot to divide the value by 4.
I used pi r square. Oh, I didn't take r, is it? I took a diameter.
Yeah, so you need to divide it by 4. It will be 1 point something.
1.1309.
1309.
Yeah.
So after substituting that, this value comes as 968.
Okay.
Okay. So if you're taking pi r square, make sure that you're substituting the value of radius over it.
Yeah.
Okay. So now the things are correct. Okay. I was skeptical, like why exactly the radiation from bottom to top is more than the total radiation being supplied. Yeah. See, the total radiation is 1400. So whatever the bottom is radiating to top should be less than that.
Yeah.
Part of it getting absorbed by this. So now things are very easy. Total radiation is 1400, right?
Yeah.
Since the total radiation is 1400, so you can say 1400 is equal to Q21 plus Q23.
Yeah.
Right?
And you found Q21.
No, we have it. We have Q21.
Yeah. We found Q21. So you
Yeah.
used it to find Q23, is it?
Q3 would be simply 1400 minus answer.
Okay.
51.195. Okay.
Yeah.
So now we have this Q23. We can equate it over here. Right?
Yeah.
You must be thinking, why are we doing this? Because they have asked us the temperature of the surface.
Okay.
Okay. See, we have T2 temperature. We need to find T3 temperature.
Okay.
See, we have got 2 answers already. We need to find a third answer. The 2 answers were Q21, what was to be calculated, we calculated by this relation.
Yeah.
Q23 was asked, we used this relation and we got the Q23.
Yeah.
Now that Q23 can be equated to this formula.
Yeah. Can.
Now in Q23, we know sigma, we know T2, we know epsilon 2, we know epsilon 3. We want A2 and F23. Once we know A2 and F23, A2 also can be calculated. A2 is pi by 4 d square. A2, A3, everything is there. We have all the areas.
Okay.
So all we need is F23. Now tell me how to calculate F23. You tell me how to calculate F23.
How to calculate F23?
Yeah, tell me. It is in front of you.
So you remove off the A first.
No.
From your denominator.
No. F23 can be calculated from here.
Oh, from those equations. Okay.
You need to know these formulas, okay? I will recall, or maybe I will revise it for you. It will get easier for you. See, first of all, we know that F12 is equal to F21.
Yeah.
So this F21 is equal to 0.16.
Yeah.
This F22 is 0. You know why?
Because it cannot fall back on itself.
Oh, yes, it's a flat surface.
Yeah.
So flat surface will have F22 with respect to itself 0.
So 1 minus 0.16 would give you F23.
Yes.
Okay.
How much is it? Tell me. 0.84.
84, yeah.
Yeah. So this 0.84 need to be substituted over here. And this entire equation only T3 will be around.
Okay.
Again, you will need calculator with alpha.
Okay.
No, not in this case. In this case, you can calculate the denominator and take everything as a root of T3, fourth root of T3.
Okay.
You can do that, right? Simplifying the equation.
Yeah.
So that is the only part in this question left now.
Okay.
You want to do it now? You can do it.
Now?
Yeah, you can do it if you want.
Okay.
If you need any help in any step, just let me know. Just do one thing. You have Q23. Just write this equation yourself. Okay.
Yeah.
If you want value of any of the term, just let me know. I'll
Okay.
explain. Go through the radiation lecture once, okay? I have
Yeah.
taught all these relations.
Yeah.
You remember, I have taught about the shape factor and the relation. So once you revise it, it will get easier for you.
Okay.
Could you solve it?
Doing it now.
Okay.
It's 5.67 times 10 to the power minus 8, right?
5.67
times 10 to the power minus 8, right? For the sigma.
Yeah.
Okay.
Yes. 5.6 and 10 raised to minus 8.
Okay.
Okay, fine. Just go for it. Just go through it.
Okay. And now?
No, not today.
Yes, please.
Not today. It's late.
Okay. Yeah. Okay. So we'll stop here then. I will go through these and then I'll let you know about the theory portion.
Okay, sure.
Okay, thank you so much. Thanks.
Good night. Good night.
Good night. Bye.